Hello and welcome to Unit 1 Video 8. This lesson is on vocabulary and graphing lines, linear functions. So first we're going to start by defining a linear function and discussing some of its properties, including the domain and range. So we're going to start by defining our linear function as for f of x to equal ax plus b, where a and b are real numbers. Our domain, or the input for our linear function, will be the interval of negative infinity to positive infinity, which was already defined as the set of all real numbers, and we had a symbol for that, and that was the double R. So you may write it as an interval, or we may write it as the set of all real numbers, the double R. Now the range of our linear function depends on if we have a equal to 0 or a not equal to 0. And I'm going to start with a not equal to 0, because more often than not we will find that we actually have a value for a that is not 0. So we're going to start there, and if I have a not equal to 0, my range, my output values, is also all real numbers. However, in the single case where a equals 0, then I will have f of x equals 0x plus b, or f of x simply equals b. No matter what value of x I choose from my domain, my range will always be b. So this is a very limited set for my range. It is b. Next two things we're going to define are the intercepts. An x-intercept is where f of x equals 0, where the function crosses the x-axis. If we were to, and this is written as x comma 0, an ordered pair that is on the x-axis. Our y-intercept is where f of 0 is used, where we have 0 for our x value and we're looking for a value of y on the y-axis. So this will give us f of 0 equals 0 times x plus b. F of 0 is therefore b, and 0 comma b is our y-intercept. We have two types of special linear equations. The first one is going to be f of x equals a constant. I'm choosing the constant -3. Here we will have our input values, our domain. Okay, and we said in the last slide the domain of anything in this form is all real numbers. And I'm going to show you that using our set. So I'm just going to give you some examples. Since we're talking about all real numbers, I'm going to go with that ellipse of ... 0, -1, ... and so that should be a positive one. But our range, as stated on the previous slide, is the b value. So our range is -3. And that means that every value here produces even the numbers that aren't listed there, because we are talking about all real numbers, produces an outcome of -3. And this will lead us to, for every x value, we will have a y value of -3. And I can't even put all of the points, they're infinite. And we get a horizontal line. Our second special type of linear equation is if I have x equals a constant. Now this isn't written in a function notation for a reason. My domain, as stated, or as looking at this, is, well, it's 4. My x value is 4. It's the only x value I have. My range is not limited in this case, and it is all real numbers. So I can have all sorts of numbers. I should point out that I may also have integers and rational numbers in here. All of my real numbers. I listed in the previous example -1, 0, +1. Mostly because that's what our tick marks will often say on our graph, but we need to recognize that this also includes numbers that are not integers. So this is all sorts of numbers, and I will include our ellipse, the dot, dot, dot in there. However, this 4 belongs to all of these numbers, produces all of these outputs, and this is not a function and cannot be written in function notation, which is why it is just written as x equals 4 instead of f of x equals a value. Well, this will produce that if my x value is always 4, no matter what the y value is, I will have a vertical line. So we're going to graph some lines here, and I've got two forms of lines that we're going to graph. The first one is our slope-intercept form, and this form is written f of x equals ax plus b. Okay, and we have two ways to graph this. So I'm going to give us a function here, f of x equals -1/2 x plus 4, and I'm going to demonstrate two different ways we could graph this. I may graph this using intercepts, which means that I need to find where f of x equals 0, and I need to find f of 0. So where f of x equals 0 sets me up for a simple two-step equation to solve for x, and I will get x to equal +8, leaving me with an intercept of 8, 0. I can also substitute in 0, and I would have f of 0 equals -1/2 times 0 plus 4, or f of 0 to equal 4, and that gives me 0, 4 as my other intercept. And then I would be able to connect these. On your paper, I recommend you using a straight edge, and your ID is a fabulous straight edge. You can just lay it down on the paper anytime you're in class or outside of class and create a perfect line there. The second way we could graph this is probably more familiar to you or more frequently used, and that would be by identifying the slope and the y-intercept. These are easily identified, which is how this form gets its name, the slope-intercept form. So if I have f of x equals -1/2 x plus 4, I would first probably identify that my y-intercept is 4, and I would identify that my slope is -1/2. So I would plot my point. I'm going to change pens. You're going to see we're going to get the same line. Oops. So I would start by graphing my y-intercept, and I would be able to graph other points using the slope of -1/2. And I will get the exact same line. The second way we're going to graph lines is in a different form, and this is our standard form. And our standard form is ax plus by equals c. And we have to note that a, b, and c are integers, where a is greater than or equal to 0. So we'd like to keep our a positive, okay? And all of these numbers are integers. So on a side note, I'd like to say that if we have an equation in standard form, and this is the standard linear form, this is exactly the same line, 2x plus 5y equals 10, as x plus 5 halves y equals 5. But the second one I gave you is not meeting the requirements that all of these have to be integers. So to fix that, we would multiply all the way through by 2, and that would get us back to 2x plus 5y equals 10. So if we are asked to graph in standard form, you will first need to put it in standard form, and in this case, this equation here would have to be rewritten by multiplying all parts by 2. So now that I have said that, we are going to look for our intercepts. So to find my intercepts, if I want to find an x-intercept, I will replace the y with a 0. So to replace the y with a 0 will give us our x-intercept, because I have no height, a y value of 0. So x equals 5. Remember, y was 0. To find the y-intercept, we would replace y. To find the y-intercept, we will replace x with 0. And that will leave us with y equals 2. Well, 0 was our x value. So I have 5, 0, and 0, 2, and we can connect these two. Remember that your intercepts do not have to be whole numbers, or integers for that matter. They may be decimals and fractions in which you use an approximation to graph them. So your assignment here, we'd like you to try on page 221, numbers 1 through 18 all. And there'll be some matching in there. There'll also be some graphing. And you should have received some graph paper from your teacher. And then also please take a look at numbers 45 to 50, which is on the following page. And you'll be looking to identify the slope and graph the line. We'll see you in class.